Okay, so for number 3 on here, we're going to do it just the same way we did number 1. We're going to compare the corresponding lengths. So 18 over 54 equals 27 over 81. And really we're saying, does it equal? Does it equal?
Yeah.
Yes. What do I get if I reduce either one of those?
1/3.
1/3. So that's my similarity ratio from left to right. And there's something I actually forgot to mention on this. Personal pet peeve is that sometimes you'll see math texts and whatever, math resources, use scale factor when they mean similarity ratio. Technically there is a difference. So we're really saying similarity ratio. And specifically on all of these, we're going to use the similarity ratio, because similarity ratio, you really have to know which way to go. We're going to go from left to right, or in other words, left over right. So on all of these, anytime it says scale factor, think of that as the similarity ratio left over right. Okay, so down here on number 5, what does SA stand for? Surface area. So it says each pair of figures is similar. Use the information given to find the scale factor of the figure on the left over the figure on the right. And again, that means similarity ratio. You don't have to write it every time, as long as you understand that that's what we're talking about. Okay, so if they're giving me the surface areas, then if I put one of them over the other one, what I will be finding is the ratio of areas, because that's what these are both. They're both areas. The ratio of the areas is the what of the square of the, I just gave it away, didn't I? The ratio of the areas is the square of the similarity ratio, right? So what I would do is I would simplify that first. That's going to make it easier for you. If you're using a multi-view calculator, that makes life a lot easier. If you type it in, 396 divided by 275, it'll tell you that that is what? Bingo. Okay, and you know that that's the area ratio, which is the similarity ratio squared. So if we just want the similarity ratio plain, unsquared, we're going to have to take the square root. So that means square root of 36 is 6, square root of 25 is 5, and that's my answer. Okay, look at number 7. Same thing happens there, except what's different? They gave me volume instead of surface area. So if I put one of them over the other one, then I'm dealing with the volume ratio. Sorry that I made the worst fraction in the world for some reason, but that's this one over this one. Again, I would do the same thing. I would start by reducing it. Thank you, 125 over 64. And that's the volume ratio, which is the similarity ratio cubed. So that's already cubed. So if I just want the plain similarity ratio, I have to uncube it or take the cube root. Okay? There's a lot of ways to do that. Here's what I'm going to advocate, partly because I want you to remember that it's the same thing. And that is using a fractional exponent if you're going to use a different root. In other words, cube root is the same as to the 1/3 power. If I want the cube root, I can raise it to the 1/3 power and get the same thing. For instance, what's the cube root of 8? 2. Okay, so if I go 8 and then I use the little caret button right there, caret, and then if you have a fraction button, you can use that, or you could just put it in parentheses. 1 divided by 3 is 1/3. So that's 8 to the 1/3 power, I get 2. So in this case, I can put it in as 125 over 64 to the 1/3 power. Now this one doesn't give me fractions, so I'm going to have to sort of use my imagination, or I could use, it'll change it to the fraction for me. It's 5/4, indeed. Okay, which makes sense. Once you got it on your calculator, it should make sense to you. 5 times 5 times 5 does equal 125. 4 times 4 times 4 does equal 64. So that's my answer here. Okay, questions on that one? Okay, on the back, I want you to look at number 12. Okay, this time it says the scale factors given. So that's my similarity ratio. So my similarity ratio is 4/9. So that's just the ratio of side lengths. So if the ratio of side lengths is 4/9, what's the area ratio? Good. 16 is 4 squared, 81 is 9 squared. What's the volume ratio? 4 times 61, 4 times 16, because this is 4 times 4, multiply times another 4, you get 64, and 81 times 9 is 729. I agree. So here's the deal. They're asking me to find a missing surface area and a missing volume. So the key is, if I'm going to work with surface area, I have to use the area ratio when I set up my proportion. If I'm going to work with volume, I have to use the volume ratio. So you have to specifically use the ratio that goes with whatever it is you're dealing with to set up the proportion correctly. Now they tell me that the surface area and volume of the smaller figures are given. Okay, so if I'm going to set up my proportion for surface area, I'm going to say, let me use the area ratio, 16 over 81. If this is the smallest one, where does it go, on top or on bottom? On top, because 16 is the smaller number out of these two. So if I'm setting it up 16 on top of 81, then the smaller one needs to go up there with the 16. So that's 256 over, and I'm going to use SA for surface area that's missing. And then I'm just cross multiplying to solve. You got it. I'm hearing it. 1,296. Okay, so I used 16 over 81 to set up the proportion because it's the area ratio and this is a surface area problem. Next problem I'm doing is a volume problem, so I'm going to use which ratio? Volume ratio, which is the cubed one, the 64 over the 729. And again, they already told me this was the smaller figure, so that means this number is going to go on top because 64 is smaller. Sorry, I'm losing my voice over here. How do I solve that? Yeah, if I can pick up the calculator well. Okay, so my volume is 17,496. Okay, questions on that one? Okay, let's look at number 11, just because I want to talk about what's happening here. Number 11, you're starting with surface areas. That's the only ones that you can compare directly, because that's the only one you have both of. So you're going to have to start out by putting surface area over surface area and say that's the area ratio. Can somebody simplify that for me? Okay, so that's the area ratio, so that's the similarity ratio squared. So if that's the similarity ratio squared, I can now figure out the similarity ratio. I take the square root of the top and I get 8, square root of the bottom. Okay, then it's like I'm going backwards, I'm working backwards so that I can then go forward. Now I can take that similarity ratio and do what to it to find the volume ratio? Cube it. Okay, so go ahead and cube that, and my volume ratio is 512, I think, over 125. Is that right? Yes. And that's going to equal this number over the other one, I think, which, how do I know this goes on top? Well, because I used solid one on top here. I used the number from the left side on top here, so it's going to have to go on top here as well. Okay, so I'm going to cross multiply to solve this. And I had a feeling we would make it farther in this class than we did in, was it 5th period? So, or actually maybe 5th period made it this, but definitely than we did in 3rd. So that's why I'm making a video to show them. So everything we just did was on video. So say hi to my other students.
Hi, Jack. Kaden. I love you.
And on that note.